Hello guys, welcome to Dr. Science. So today we are going to talk about iron deficiency anemia. So this is going to be a three-part video, and in this video I'll be mainly talking about how iron is getting absorbed into the body, and not only that, I'll be telling why iron is needed for red blood cells. Okay, so basically, as you know that, suppose this is a red blood cell. This red blood cell is going to contain a lot of hemoglobin in it. There is a lot of hemoglobin. So basically, you will be when we talk about hemoglobin, there are, suppose this is hemoglobin. The hemoglobin is going to contain heme and globin. Okay, so this is a ring, and on this ring there are pyrrole rings again. Now this is called as a protoporphyrin ring. Okay, and to this porphyrin ring, if we add iron in the middle, now this entire complex now is called as heme. So basically, what is heme? Heme is nothing but iron plus protoporphyrin ring. So to this heme group there is a chain. Now this chain is called as your globin chain, and as you can see, the entire component is your hemoglobin. Heme plus globin is equals to hemoglobin. As you can see here, if there is no iron, there will be if there is no iron, there is no hemoglobin. If there is no hemoglobin, obviously the RBCs don't have enough hemoglobin, and if there is less hemoglobin, the term we call it as anemia. Anemia is when there is low hemoglobin in your red blood cell. So basically, how this iron is getting absorbed into the body, that is the question. So basically, we get iron from our food, and basically you and me, we will take food from meat. Okay, and the meat is going to contain iron, and not only that, we will take vegetables or fruits. Okay, and they also contain iron. Now the question here is, the meat which is containing iron is far more superior than the meat which is present, the iron which is present in your vegetables and fruits. So why is that? Because meat contains an iron called as your ferrous form of iron. Okay, ferrous means Fe2+, whereas vegetables and fruits contain ferric form of iron, which is Fe3+. Now the ferrous form of iron, it is the absorption rate is very high. Okay, the absorption rate is very high compared to the ferric form of iron. Hence, meat is a good source of iron. Okay, now the people who are veg, okay, they take fruits and vegetables which contains your which contains your ferric form of iron, which is Fe3 plus, right? So obviously they are this iron is not good in absorption, so they will get iron deficiency. So obviously if there is no iron, there is no synthesis of heme and globin, and hence they can develop iron deficiency anemia. Okay, compared to non-veg people, non-veg people, they have a lot of iron stores because the iron there is Fe2 plus or your ferric form, ferrous form. Okay, so basically suppose this guy is a vegetarian guy, unfortunately, and he have taken the vegetables or fruits. As I already told you, vegetable and fruits contain Fe2 3 plus. Okay, Fe3 plus, which is your ferric form. Okay, now this ferric form will go into the stomach, and from the stomach it will go into the duodenum. Okay, suppose this is the duodenum, and in the duodenum it gets absorbed into the duodenal cells. And not only that, in the jejunum, vitamin B9 gets absorbed, which is your folic acid. And not only that, in the ileum, vitamin B12, which is your cobalamin, gets absorbed. Okay, so I will draw this cell, this duodenal cell here, for better for a good drawing. So this is your duodenal cell, and this guy is a vegetarian, and he is getting the ferric form of iron. Now this ferric form of iron is converted into Fe2 plus. Fe3 plus is getting converted into Fe2 plus by the enzymes present here on the duodenal cell wall. So basically Fe3 plus, which is containing 3 positive ions, is converted into Fe2 plus, which is having 2 positive ions. So basically there is a reduction going to take place, hence the enzyme here is your ferric reductase. Okay, so what is the enzyme name here? It is ferric reductase. So now this Fe2 plus form needs to enter the duodenal cell, hence there is a transporter which is present on the duodenal cell wall, and this transporter name is called as divalent. Why divalent? Because it is taking 2 plus form of iron, or Fe2 plus, hence it is called as divalent metal transporter, or simply we can call it as DMT. Okay, so now the Fe2 plus have entered the duodenal cell. Okay, now this Fe2 plus or the iron can have two fates. Either it can enter into circulation, or it can be stored in the cell, or it can act as a storage organ. Okay, storage form of iron. Okay, this circulation part I will talk in the next video, but here I will talk about the storage form of iron. So basically, suppose this is the cell. So Fe2 plus has now entered into the cell. So I will draw the Fe2 plus as some dots. Okay, this is free iron. Now this free iron is dangerous because free iron, it's like a nuclear bomb, and it can damage the DNA or the lipids present in the cells. Hence this free iron have to be stored in some kind of bag. Okay, so this bag here is called as apoferritin. There are apoferritin bags in the duodenal cell. Now once the free iron and the apoferritin fuse with each other, this is apoferritin bag and this is the free iron which is entered into the apoferritin. Now newly formed molecule is called as your ferritin. Okay, so once again I am going to say, this is apoferritin or your empty bag, and this is your free iron which has entered the duodenal cell. And once they fuse with each other, the apoferritin and the free iron, the newly formed compound is called as your ferritin. So basically ferritin is nothing but apoferritin with free iron. Okay, now this ferritin, suppose this is a ferritin can fuse with a lot of ferritin molecules. Okay, suppose these are lot of ferritin molecules which are fusing with each other, and once they fuse with each other, the newly formed compound is called as your hemosiderin. Okay, so what are these? Are your storage form of iron. Okay, storage form of iron. So in the exam they may ask, what are the storage form of iron? The storage form of iron are your ferritin and hemosiderin. Sorry for that, I am feeling unwell lately. So the storage form of iron are your ferritin and your hemosiderin. So I will talk about the circulation part of iron in next part, because I want to keep the video as short as possible. So basically I will talk about the summary. So here is the duodenal cell, and in the duodenal cell there are presence of enzymes which are your ferric reductase, which will convert the Fe3 plus into Fe2 plus. Once Fe2 plus is converted, there is a transporter called as your DMT, divalent monotransporter, which will transfer the Fe2 plus inside the duodenal cell. Now this Fe2 plus has two fates. Either it can enter into circulation by a port. There is a port present on the basolateral side, and this port is called as your ferroportin, and through that the Fe2 plus will enter into the circulation. Okay, I will talk about the circulation form of iron in my next video. Or the other fate of the the iron is to get to convert into storage form of iron, which are your ferritin and your hemosiderin. So that was about it. Thank you guys.